Well, g'day and welcome back. I can't say welcome back to the shed because I've actually got this radio inside, and this is an STC, I believe model 53, at least it has model 53 on the chassis. However, I couldn't find that listed anywhere. I've got a couple of models with chassis number 53, and I think that's probably what it is. I've downloaded a schematic from Radio Museum and I'm hoping it matches what I've got. Now this radio belongs to a friend. He's asked me to get it going, fix it up, and he's also asked me to see if I can fix up a few little blemishes on the cabinet. The cabinet's pretty good, really, I've got to say. Now, it's about 40 degrees in the shed today, so I'm not going to work down there, but what I am going to do is take the chassis out of the cabinet, take the chassis down the shed, and when it cools off a bit, I'll do a bit of work on it there. Now, looking at the front of the cabinet, we've got a few knobs here. This one's obviously tuning, and it does appear to work the tuning dial. At least the needle is moving, although very slowly. It's a very low ratio. But he said that there was some issue with the tuning, something to do with it not reaching the end of its travel or something like that. Now this will be a wave change switch, and I noticed the switch is actually, the orientation of it is not right. It should either be that way and that way, or down here. This will be tone, I suppose, and volume. Now, I notice it's got this escutcheon piece put in here, and I don't believe that's original. I found this photo of a similar radio, and unfortunately it doesn't tell me the model number. And so I think this has been added later. Whether the front panel was damaged or there was some issue, I don't really know, but I think it's there to stay. I wouldn't be able to remove that and bring that back to its original finish, so we'll leave it like that for now. But let's get the chassis out and have a look. So just looking in the back here, we've got the field coil speaker down here with the plug intact, but the wiring looks very frayed and there's a couple of wires loose. There's a valve obviously missing there, but he's given me a complete set of valves with the radio, as well as a Carl's mains cord. He says replacement valves if needed, so hopefully we'll have everything we need to do this. Now, according to the Radio Museum website, this the schematic was taken from the Radio Trade Annual of 1938, and I would say 1938 would be probably about right looking at the construction of this set. We have a pale blue R&P sticker here with a C prefix. I looked that up, and that denotes 1936, so a little bit earlier than the Radio Museum data. But of course the Radio Trade Service Manual may have been published later. The R&P sticker probably is a more accurate dating tool, so I'm going to call this 1936, I think. And looking in here at the speaker, field coil speaker, it appears to be intact. It's labelled STC, although it looks just like the roller speakers I've seen. The output transformer is still attached to it there, and here we've got a couple of stray wires here. I'll take that out as well because I'm going to need it to get the chassis fired up. So this chassis has large bolts going right from the top down through the baseboard. I haven't seen that before, but certainly make sure that it doesn't fall out. So there's one. I've already taken the knobs out. That was a bit of a battle in itself, but they did come off eventually. One odd sized nut. All right, I'll just get some pliers onto it. So here it is, and just looking at the valve diagram on the back of it, the missing valve there is a 6F6. We also have a 6Q7, a 6K7 and a 6A8. and that agrees with the schematic I've downloaded. It's got a 5Z4 there. It's a directly heated double diode, so the filament winding will carry the HT voltage. 6A8, 6K7, 6Q7, 6F6. This diagram doesn't have pin numbers marked on it, so I might have to just pull the valve data for these valves because I'm really not all that familiar with these. This is an earlier radio than most of the ones I've worked on. I'll leave those in place for the moment. This looks like a makeshift shield. Not sure if the 6F6 requires a shield, probably not. This 5Z4 is something I'm not familiar with, and yeah, that's very loose in the socket. That has no resistance at all there. I doubt if that's making proper contact. It's just sitting there. Lucky it didn't fall out, really. Just looking at this tuning mechanism, I can see here that this has a reduction drive on it. This one turns at a much higher rate than the outside, and sadly the knob that fits over that is missing, so it only had the outer knob attached. I don't know what my chances are of getting something to fit on that. It would be nice if I could get it, but I have no idea what was there originally. I'll have to do a bit of research, see what I can find out. Maybe I can get something that'll work for it. And I think I've found what he was talking about here. Okay, so the spindle, which is this piece in here, runs directly on the edge of this brass disc here, and it reaches the end of its travel before the gang is completely closed, or just when it's completely closed. That has just dropped off the drive pulley here, so turning it back the other way, it won't go back. You need to sort of help it along a little bit. There we go. Now that will turn all the way around, and it should be a simple enough matter to adjust that. Just turn it around a little bit so that it doesn't run out of travel before it closes. Just looking at the bottom of this tuning capacitor, this looks like the remains of what may have been a rubber grommet at some point, and I can see that it's been worked on. It's had new washers put in there to take it to the correct height, and this nut only just makes it. Overall, the chassis looks clean. At least it has, I presume, been cleaned. A few scratch marks and that on it here and there. Originally painted with this bronze metallic paint, most of which is worn off. I'm not sure if I would repaint it or not. I wouldn't want to lose this this back of the chassis with the labels and everything on it. That has to be kept, of course. So let's have a look underneath, and I can't turn this right upside down or we'll damage this tuning mechanism, so I'll just tip it on its side for the moment, but I'm curious to see what we've got. Transformer side down. It is quite a heavy little lump. Now, as I said, I'm not all that used to working on radios of this vintage, but it seems to be well laid out. A number of coils there. That'll be shortwave and medium wave coils, oscillator and aerial, no doubt. This says electrolytic condenser. I'm not sure which is plus on that. Gee, it would be nice to know. Another 25 mic electro at 40 volts. That'll probably be a cathode bypass cap of some sort. What's this say? Non-inductive. Down here we have this huge can. I guess it's an electrolytic. It looks like it's been replaced. Looks like something out of a microwave oven, to be honest. I don't know what it's doing there, but I'll have a look at it and I'll see what the schematic specifies for wherever that is. I don't know what's going on with this. This is rather odd. That may have been original, but I really doubt it. Other than that, we've got this large dropping resistor down here, and I suspect that that supplies the screen voltage. I'm not sure what it does actually. Looking at the schematic, this apparently is it here, and it does appear to provide screen voltage if you follow that up to the 6A8. I guess we can probably count on this thing being open circuit anyway. It does look intact. Is that a cobweb? I hope that's a cobweb, not a wire. They are very fine. Just out of curiosity, as much as anything, I think I'll just measure it. Now this end of it goes to ground, is that right? Yes, that's right. Okay, so looking at the other end of it, hey, we have continuity. How good is that? And from the tapping, yes. So that's a stroke of luck. If that was open circuit, that'd be a bit of a job to replace. Just looking at the top of the chassis, we have one electrolytic there, and that is still wired in. One of its legs is broken off there. And there's a hole here where there used to be one, another one. And I'm thinking that that large capacitor under the chassis must have been used to replace this. Well, before I get too far into the radio, I'm going to have to do something with this speaker. I need the field coil to be working in order to put power through it. I mean, I could jumper something up, but really it looks a bit of a mess, but it's going to have to be fixed. This output transformer is a different colour to the speaker, so it looks like it's been put in later, and just masking tape everywhere holding everything together. So what have we got here? This seems to be ground, like chassis. That's attached to this lug which is screwed to the chassis. We've got 3 wires going into the plug here. I guess I've got this other one here too. What's this? This one goes into the output transformer. I've got a green plastic wire being spliced in there. It looks like it's got a burn on it, but it's not all the way through. So let's look inside the plug and see. Okay, so there's one wire off there, and one wire off there. It all looks pretty grim, really. I think there is a diagram here. Okay, now this doesn't have pin numbers on it or anything, but goes through the output transformer. This goes to the B+, that's one of the electrolytics. Other side of the field coil will be that electrolytic, so these two will be field, ground in the middle, these two will be output transformer. I was just cleaning this up and I noticed someone has scratched some letters on here, and this one says E, so I presume that's earth. F for this one, F also on this one, T and T. That does seem to correspond with the schematic, so those two would be the output transformer. These two here, and one of them is broken off, are going to be the field coil, and this one here is ground. I don't know what I'm going to do about this missing pin here though. I'll have to see what I've got. Before we go any further, let's just see if we've got continuity through that field coil. So if that's one of the pins, and yeah, that's what, 2K, that's on the 1K range. I put it on 100K, check for 0, yeah, just over 2K. 2.5K, 2.23, something like that. I'll use the digital one to get a more accurate reading, I guess. And the other thing is, I guess we want to check the output transformer. Let's see what we've got. Nothing. You might have nothing on the output transformer unless I'm mistaken. Could be this one. Ah, there we go. Yep. So now we're looking at the output transformer, and we've got 5 and bit K, 6K. So that's probably alright. I didn't hear anything from the speaker, but of course the field coil isn't energized. You sometimes get enough residual magnetism in there to hear something, but no, I'm not hearing anything at all. I wonder if I can pick up the voice coil. Where does that come off? There. Might hear something if I do that. No, but we've got continuity anyway. Alright, let's see what we can do with this mess. Okay, just rummaging through my junk and I found this valve base. Came off another radio that I worked on quite some time ago. And looking at it, the pins might do the job. It's got two thick ones and a number of thinner ones. The thinner ones are just on 3.1 mil. Have a look at these. These are 3.1 mil. So I guess if I can get one of them out and put it into there, we might be in business. Could even maybe use some of that wire, I don't know. Okay, let's see what we can do. Getting this pin out of this valve base is not as easy as I had hoped. I've been trying to bend over the little edges where it's turned over, and the pin is loose, but it's not willing to come out easily. I guess I can either break or cut the valve base. I mean, I'm not going to use it for anything anyway, or just try and pull it out with the thing in the vise. One way or another, I'm going to get that pin out. There we go. So I'll clean that up a bit and see if I can put it in. I was just drilling that pin out, and it was all going fine, and then suddenly the drill snatched and it broke out the Bakelite around the edge. So I've got tape on it that'll hold all the pieces together. And I'm going to see what I can salvage from this. I should be able to put it back together with the new pin in it. The pin will go there. That will work. But I need to now glue this back together. Okay, so I've got the plug taped to the bench top so it can't escape, and I've got the new pin in here and taped to the one next to it to maintain it in position. And what I've done is I'm just getting the tiniest amount of bicarbonate of soda down in here, or sodium carbonate or whatever you want to call it, and I'm going to put super glue on this. Obviously this stuff catalyzes super glue pretty much instantly, and that will hold the pin in, I think, pretty solidly. Unfortunately, that's run down around the thread, so that's going to be a problem for me, I think. Anyway, I'll put this in. I think it goes that way. It doesn't look right. Maybe it goes this way round. Yes, that looks better. Yes, that looks right. And this piece goes in here. And those threads seem to run okay. Alright, I'll let that set for a few minutes, and I'll just tape that down and leave it for a few minutes and let it go off. Well, this thing is proving to be difficult. Nevertheless, I've got the pin in after a bit of a struggle, and if I'm lucky, yeah, I can unscrew the back. I've put a good deal of bicarbonate of soda in there and super glue. Unfortunately, the super glue ran around to the bottom. I tried to fix that up, scraped it out, stuck my finger to the bench, stuck the plug to the bench, stuck my fingers together. I might just call it quits for today, go inside, have some dinner, and come back again tomorrow when hopefully I'll make less of a mess of things. I've finally got the wiring in the plug sorted out and soldered in, and the back screws on at last. The new pin is a little bit longer than the others, but I don't think that's going to make any difference. It should plug in fine. Yep, that should be okay. There's one thing I forgot. I intended to put this braiding over the wiring. Now I've heat shrunk it and soldered it on. I forgot all about it. So I had to go down to the local electronics shop anyway for something else, and I found this self-closing tubing which wraps around it and closes itself. I'm going to try putting that on. At least it'll be neater than leaving it like this. And so there we are. It's worked pretty well. This stuff stays quite firmly closed. I put some heat shrink on the end there to hold all the wires together, and that just folds in and it doesn't come off. Pretty tidy. I put a little strain relief strap on there and some heat shrink around this end of it, so that should be safe enough. I will come back and clean this speaker up, but for the moment I just want it working, so I'll leave it at that for now. And when I'm cleaning up the chassis and whatever, I'll deal with this rust and stuff. I've fixed up the cone where it was split, and there was another split around here that I later saw. But I did manage to get it to, well, it's scraping a bit again now. I had it not scraping it for a while, but never mind, we'll deal with that. One problem I can see with this speaker is that, and it's kind of a design shortcoming, is that there's absolutely no protection against dust for the voice coil. Because of this suspension type here, there's no spider at the back and absolutely nothing to stop dust getting into that voice coil. All I can do is clean it out as best I can, but it's still obviously got some crap in there. I've made up a stand for it so that I can turn the chassis over, and that only just clears this tuning disc. I should have maybe made that 5mm longer, but anyway, I was just checking this and I noticed that this tuning capacitor seems to have been bent in a little bit there. I'll be willing to bet that that's short. I'll just check it, but I'll be willing to bet it's shorting. Let's just have a look. Oh yeah, there we go. Hardly surprising really. I'll check the other one just to be sure, but it looks slightly pushed in, but I don't think it's, well, it may or may not short. Let's just have a look. No, it's looking okay, I think. So I'll just have to very carefully bend this one back out. Okay, so I'll just use a razor blade to try and bend this out gently. That might be enough. A little bit more. That looks about okay. Alright, I'll just run that through and check it, but I think that'll be fine. Oh, this thing's still shorting. I'm going to leave it for now. I'll need to get in there and have a really good look. I'll probably have to take that tube out and maybe take the front off and just work out what's touching, because I can't really see it here easily. And this has got me sidetracked from what I really intended to do, which was to check out the power supply. So I guess the next thing to do is to turn it over and start tracing through the power supply section. There we go. Well, first things first, and I noticed someone's fitted a new power cord here, and it has these push-on connectors here. I don't know if they just happen to be a lucky fit onto these tabs here or not. We've got the active on here, sorry, the neutral on here and the active onto this one. And looking at the other side of that board, yeah, that's where the active and neutral come in. I bet that used to be a fuse there. I wouldn't be surprised anyway. Possibly I should replace it with a fuse of some kind. So the active is attached to this side and it goes straight down here to this point on the transformer. And these two will be, I think, voltage taps. So I'll just clip this onto the neutral back here. So that one is about 2 ohms off the neutral, and that one is 0. So it's connected to this one, which goes to a tap marked 240. So it's on a 240 volt tap. So these two wires are marked HT, so I presume that's the secondary. Let's just see what we've got across the secondary. I'll put it on, times 10 maybe. So that's about 400 and something. I can't really look at the meter straight, but it's about 450, I think, ohms on the secondary. So looking across the primary, and we've got not much. That's on 1, so that's just over 10 ohms on the primary, which is not as much as I would have expected to see. Of course, I'm not familiar with these radios. Could be the primary's wound with very thick wire. In fact, looking at that, it looks to be. That worries me a little bit. That said, there's no sign of burning or anything. Okay, I suppose a lazy way of checking the filter, the power supply filter, is that this is the speaker plug, and I know that the field coil is connected again across these two outer pins here. So this one goes to the rectifier tube, as you'd expect. This one goes to, I presume, the plate of the output tube. It goes to the tube socket anyway. That has this yellow wire which runs along to the filter capacitor we saw on the top of the chassis. And I don't hold out very much hope for that one, although it's not bulging or anything. It might be alright for the moment. But I don't trust electrolytics. This is a 1930s radio. It's very old. Now the other side goes to, well, obviously the output of the rectifier tube, and I can't quite see it, but I suspect it comes out here, which would suggest that this capacitor has been used to substitute for one of the filter caps. Okay, so I've got the meter on buzz. I'll clip this to that side of the field coil and we'll just check this through, but I think, yep, that one, and what's the better goes to here. Yep. So this is our second half of the pi filter on the power supply. Let's have a look at what it is. It's a strange looking thing. So this is a 5 microfarad 500 volts AC, and it's a non-polarized capacitor. It would have done something, but I'll replace that with something more suitable before we go any further. Just looking at the schematic, good idea to do that from time to time, I guess. Here are the two filter capacitors, and gee, it's really hard to read. The printing is very small. I'm pretty sure that says C4 and C3. It's a bit like trying to read fly spots or tea leaves or something, but now if I look at this C4 16 microfarad, that's what I expected. Down here it says C3, and I'm pretty sure that says 8 microfarads at 600 volts. So it looks as if that 5 microfarad non-polarized cap that I took out wasn't all that far off. I'll still replace it with an 8 because I've got some 8s there. I don't have any 16s left. I've put in an order with Carl, but they're not here yet. So I will put a couple of 8s in there to make up a 16, and that should take care of the filter side of it. then we'll just see where we go from there. But I might try firing it up without any valves in, just check the voltages we're getting off that transformer, because I worry about that 11 ohm primary on the transformer. If that's shorted, we're wasting our time pretty much, or I'll have to get it rewound or something. I've replaced that 8 UF capacitor, put in a little tag strip here to hold it and an earth point there. I don't have a 16 UF, I've got some on order, so I've just roughly tacked these two together to make up a 16. I'm just going to put it in there, and when I get the 16 I'll replace it. I don't want to shorten the leads, because I may use these for something else and I might need the lead length, so I'll leave them like that, ugly as it is. Okay, I've got those caps soldered in. Now I've taken out all the valves, including the rectifier, so there's nothing going anywhere. In any case, the speaker isn't plugged in. And what I've got here is that this meter is connected to the secondary, the main secondary high tension, to the transformer, just to see what we're getting there. Now that will be a pretty meaningless figure because it's unloaded. I just want to make sure that we are getting something vaguely appropriate. This meter is connected to the 6.3 volt filament winding, and if that primary is correct, and I thought 11 ohms was very low for a primary, but if it's correct, then we should get 6.3 volts there, so that the turns ratio will be right. So I've got it on dim bulb to start with, just to make sure nothing's going to go bang. So nothing for it but to turn it on and see what we get. Okay, only a faint glow from the dim bulb. I would have expected less than that, perhaps, I don't know. 730 volts AC on the secondary. I don't know why that's varying, but as I said, that's pretty meaningless really. What's important is we've got 5 and a bit volts on there. It doesn't look as if anything's going up in smoke, so I'm going to turn the dim bulb off and see what voltages we get then. So 830 there, and this is just over 6 point, that's 7, so 6.2, 4, 6, yeah, so 6.2 on this meter. Well, I'll give it a volt either way. That actually looks good. It means that the primary isn't shorted, or we wouldn't be getting correct voltages there. So that's encouraging. Okay, so this time I'm going to just see what we've got on coming out of the rectifier tube. I put the valve back in, still no other valves in. I'm going to put it on dim bulb anyway, just in case something goes bang. Here we go. Nothing yet, and the dim bulb's okay, so I'm going to full power. And it's coming up. 552, 3 volts. Okay. Okay, for the next step I wanted to connect the speaker, and there's a lot of very dodgy looking capacitors in there, so I thought I'll just draw out what will be energized when I plug in the speaker. So here's the power coming out of the output tube. We've got the field coil there. That feeds power to the screen on that side and to the plate on that side. Up to that resistor to the plate of that tube, but that's not in, so nothing will flow there. Same with the IF here. There'll be no current through that because the tube's not there. Same here. So the main vulnerability I can see is this capacitor here, which goes across from the screen voltage line to the plate voltage line, and it's paper. It could be dodgy. I can't see any paper caps to ground that are going to be energized, but of course, oh, actually, there's one here, C6. C6 is a 0.5 mic paper, yeah, so that one there is something to watch as well. I will leave it as it is anyway. I just want to plug the speaker in and see what happens, but I really need to watch that. In fact, maybe I should have a look at C6 before we start. Okay, so it turns out that this is C6 here, and it says 0.25 microfarad, 600 volts, but this goes to that screen line. I can pick up the other end of it down there, so I guess that must be it. 0.25. It's a 0.5 mic here, so why would that have a 0.25 on it? I really don't know. There's another very dodgy looking capacitor here. The lead screen, it's cracked. I don't know if it was once round, but it's certainly elliptical now. That may be the way it was. There's another elliptical looking cap here. I'm hoping that that's just the way they are. They'll all have to be replaced, of course. So plugging the speaker in, and the ground goes that way. Yep, that's in. And this time I've got the meter connected to the filtered B+, that is the B+ coming out through the field coil and through the second lot of capacitors. So here goes nothing. Put it on dim bulb again, see if something goes bang. Not too badly. We've got some voltage coming up there. I think I'm confident enough to take that off dim bulb. We've got 297. Oh, 429 it's jumped up to. 420. Yep, 430. Okay. And proves we've got continuity through the field coil as well, of course. And what I might do is just have a quick look at the B+ going into it. Just taking that, switching it off, and switching it back on again. And we've got 505 going into the field coil. Okay, so far things seem to be functioning as they should. Nothing's gone bang. What do we do now? I'm wondering if I dare plug a valve in, or whether I should go replacing a couple of those caps. The output tube, I will at least want to replace the grid coupling cap. I don't want to blow up the good output tube that my friend gave me with the radio. So yeah, we might do that next. Okay, just replacing this grid coupling cap. It's easy enough to trace components on here, even though they're mounted on this board. It's easy enough to follow the wiring around and check it with the meter. So now I'm going to put the output tube in here. It's a 6F6, and it's one that I believe is new old stock that my friend, the owner of the radio, provided. I don't want to damage it, so very carefully take it out. It does look brand new. And plug it in, and we'll see how we go. And plugging in the speaker. I'm not sure if I want it upside down or not. Perhaps it would be an idea. And if this is working, we should theoretically hear a buzz from the amplifier. I've got the speaker plugged in. This time I've got the meter on the plate of the 6F6 output valve, and I'm going to try it on dim bulb. We'll just see how we go. Nothing alarming yet. We're starting to get some voltage coming up there. .282 volts. I'll just go off dim bulb and see how much it comes up. 416, 417. I'm not sure what its maximum plate voltage is. Probably shouldn't put it on there without any other load on it. Now, I'm not hearing anything from the speaker, and I was hoping that I would hear something when I touched the grid, the 6F6, but I'm not hearing anything from there either. So I'm not too sure what's going on, but there's a lot not going on. Alright, well, let's just switch it off and see what's happening. I thought that before I turn it off I'd have a look at the other voltages on that valve. And then I just noticed that I am getting some sound from the speaker. I'll just hold the microphone near it. And that does decrease when I turn the volume down. I've got the volume up full at the moment. So that means at least the voice coil's intact. I'm still not getting any sound when I touch the grid. I don't know if I should be. I probably should be. Alright, so let's have a look at the screen, and it's on pin 4. 273 on the screen. The plate is pin 3. It's got 248. 248. 273, so I've got more on the screen than we have on the plate. A little bit odd. What have we got on the cathode? The cathode is pin 9. That's that one there. Nothing. 0.16. I put it down to 20 volt range. 16 volts on the cathode. Yeah, well that that cathode bypass cap is pretty dodgy looking anyway. I think I'll change that for a start. Because the new capacitor is so much smaller than the original, I'm just going to have to put a pigtail on here to make the component leads reach. I'll just solder that up. That will do nicely. And I'll put a bit of shrink over the positive side of it, I guess. So there it is there in place. And while I'm in here, I may as well replace this one. This is the cathode bypass for the 6Q7, and no doubt it'll need doing as well. This one here is on the tone pot. I don't think it's going to be an issue. It's got not much voltage on it. I guess I could replace it, and that board will then be complete. I've checked the resistors on it and they're all pretty good. In fact, speaking of resistors, I thought these things here were inductors of some kind, but they are wire wound resistors, and the ones I've checked have been spot on. I wouldn't imagine that they would drift much at all. There's a few dog bones in there, and so far they've been okay. Okay, so let's just snip this one out. I think it's 25 as well. So, Ducon condenser, electrolytic condenser, type 61, 25 microfarad, 25 working volts, and it must say there somewhere which end is positive. This end is red, however, when you scrape the dust off it. And you can work it out from the schematic anyway, but as it does say there, red indicates positive, do not reverse. And this end is indeed red-ish. Again, because of the size of this thing, I'm going to have to put a pigtail on it to make it reach the two termination points. And someone asked me how I do this, and Dave Tipton's got a much better method. He's got a little gadget to do it, but I just put a few turns around a small screwdriver like this. Push it in. Clip the end off. Turn that around and pull the lead out. Since I'm in here and replacing caps, I thought I may as well replace this one here. Runs off the plate via this resistor, so it goes basically to screen voltage between plate and screen. It's got a bit of voltage on it and could conceivably do something nasty. in any case, while I'm here replacing caps, it may as well go. So that will be this one here, C10, running between the plate and the screen voltage lines. Now it's a 0.006, and I checked that against the schematic and that's right, 400 working volts. Now I don't have a 0.006, I've got a 0.0047. I've paralleled it up with a 0.001, so that'll give me 0.0057 mic, near enough to 6. I don't think it would make that much difference, to be honest, but nice to be accurate or whatever if you can. So I'll just pop him in there. Okay, that's on dim bulb. Still not hearing anything much from the speaker. That's 229 on the plate, and on the screen 235. Nothing, I presume, when I touch the grid still. No. I'll go off dim bulb and see if there's any difference. And I'm starting to hear a crackle from the speaker. And I've got a little bit of grid hum there now. So that's something. Just hold the microphone near the speaker here. And okay, for some reason we've still got 17 volts on the cathode. The screen is 281, plate 256. Just looking at the valve data for that 6F6 output valve, and yep, okay, so plate voltage should be 250 out 285. Control grid voltage minus 16.5. Now we had plus about 17 on the cathode, as I recall, so this will be measured grid to cathode. So plus 17 on the cathode is the same as minus 17 on the grid. So that's probably about right, up to 20 if you've got 285. Now, amplification factor, it's got 0 when it's used in pentode mode, or at least it's not stated. I imagine it's running at very low gain, and all the gain will be in the triode preamp. So probably you wouldn't expect to hear anything when you touch the grid, or anything much. I am hearing a slight noise, so that's probably fine. Okay, after checking everything, I put the 6Q7 in, which is the preamp, and I thought I'd see if we get any buzz off the grid of it. So I'll go off dim bulb because it seems to be going okay. And certainly noise from the speaker. That sounds promising, I suppose. And that's the pickup input. So at least the amplifier section is working. That's promising. It's a good start, I think. Well, my package from Carl's Capacitors has arrived, so I now have a 16 UF cap, I think that's one there, to put into that power supply, so I can get rid of that ugly mess that I put in there. So there's that 16 UF cap where it should be. I'd have to say the general layout of this chassis, especially for its age, is surprising. 1936, and there's these two main boards here, which are really the precursor to a printed circuit board, I guess. They've got what would be the tracks on the back side of them, thick metal wires, and all the components mounted here logically. You can follow where the wires go to them. We've got all the caps changed on this one. They're the two cathode bypass caps. That one's on the tone control, I think. And nearly everything is mounted on these boards. I haven't touched this one yet, and I will have to work on this before we attempt to get the RF section working. And for that reason I'm going to have to leave this video here, and we'll continue with it in the next episode. Hope you've enjoyed watching me work on this thing. It's an interesting old radio, and I think there's a lot to do to it yet. There's that whole RF section to sort out, There's the speaker to sort out, there's the tuning dial to sort out, those shorted tuning cap. Yeah, so there's a bit to do. Anyway, thanks for watching. I hope you've enjoyed this. We'll catch you next time. Bye for now.